Hey there, did you work on these graphs before you found the answer key video? I hope so. Here we go, let's see if we agree. And by the way, if you've got this first one, fast forward to number 2. And if you got number 2 and you need to see number 3, fast forward to number 3. But in the meantime, those of you who want to see number 1, here we go. Okay, so I am graphing a trig function. The first thing I identify is the amplitude. And in this case, what's my amplitude? 1. It's the coefficient of the trig function. Since this is a tangent function, is it telling me the range? Very good, it is not. It is telling me key y values. And my key y values will be -1 and +1. Good. Okay, now what? Now you have to ask yourself, is it going to flip? What's the answer? No, because it's a positive in front of here. So this would be the graph that we should get after we finish our work. And the next thing we identify for a trig function when we're graphing, we identify the period. Now, for sine and cosine, it's 2 pi, isn't it? But for tangent, remember, one of your asymptotes for the parent graph goes from -2 and the other one's at +2. So the distance between here is a length of pi. And you're like, how do you get that? Take the larger number minus the smaller number. So you basically have pi over 2 plus pi over 2. So in this case, the formula is pi divided by b. Got it? For sine and cosine, it's 2 pi. For tangent, the parent graph only takes up half the circle, so it's pi. All right, where do we always find the b? It's the coefficient of x. So I'm basically taking pi and dividing by pi over 2. Remember, this is division. Looks like we are needing to multiply by the reciprocal. So it looks like the period is 2. All right, works for me. I can handle that. And still, even though it's tangent, you're still finding the length of each interval. Because we had negative pi over 4, we had 0, and we had pi over 4. We have 1, 2, 3, 4 intervals still. So I need to take the new period and divide by 4 intervals. So the length of each interval will be 1/2. Good? Okay, so we just found the LOE, right? 1/2. And now when we are going to start the graph, I need to know what my new asymptotes are. So we have one more characteristic to find for tangent. For tangent, I don't really have a phase shift. For tangent, and by the way, phase shifts are plus and minus inside of the parentheses with the x, okay? There is something with the x which is going to affect the asymptotes. So here's the deal. The one characteristic that we do need to find for tangent are the asymptotes. Now here's the deal. The normal is from negative pi over 2 to pi over 2. That's the normal. This one's different because I have a pi over 2 as a coefficient of x. So I need to find the new asymptotes based upon pi over 2 being multiplied to x. And the idea is to get x all by itself in the middle. So I need to get rid of the pi over 2, don't I? So what are you going to do to get rid of the pi over 2? Good, you're going to multiply by 2 over pi on all sides, which is going to leave you with a -1 less than x less than +1. My new asymptotes are at -1 and +1. And I still have 4 intervals. And the length of each interval is 1/2. So what's -1 plus 1/2? Good. -1/2. -1/2 plus 1/2, 0. 0 plus 1/2 is 1/2. And that's, one more time, gives me a 1. These are my asymptotes. This is what I just found. -1 is an asymptote. +1 is an asymptote. That is the best way to find your asymptotes when it comes to a tangent function. Are we good? Excellent. Okay, so I think we need to make a chart. So I found some space over here. Hold on. And we are going to start by plugging x's in. What are my x's? -1, -1/2, 0, +1/2, and 1. And according to this equation, the first thing I do is multiply by pi over 2. So we get -pi/2, -pi/4, 0, +pi/4, and +pi/2. Those, if you remember me mentioning in the lecture video, those are the typical angles for tangent. Yay! Because the next thing this equation tells me to do is take the tangent of these guys. I know the tangent -pi/2 is undefined. I know the tangent -pi/4 is -1. This is still 0. This is +1. This is undefined. Y'all with me? Okay. And so now, identify your points. So we have -1 undefined. We have -1/2 and -1. We have 0, 0. We have 1/2 and 1. And we have 1 and undefined. All right. Well, -1 undefined. -1 is undefined, which is an asymptote. We already knew it was an asymptote because we did the work here. This is a great verification. At -1/2, I get -1. Well, I knew -1 was a key value. At 0, we got 0. At 1/2, we get +1. +1 was another key y value. And then at +1, it's undefined. It's an asymptote, which verifies this work. So it's great. We're verifying the work that we've done. Yours is probably drawn better than mine. That's okay. But it went in the direction it was supposed to go. Are you with me? Okay, loving it. Problem number 2, coming your way. Okay, here's the second problem. Let's see if we agree. Tell me the first characteristic you identified. Good, you identified the amplitude. So what was that? 1. And what does that tell you for tangent? It tells you key y values. Got it. And what are my key y values in this case? -1 and +1. Excellent. Then what's the next characteristic you identified? Does it flip? Is it going to flip? Good, it's not. So this should be the graph we get. There's a positive in front, no flipping. What's the next characteristic? The period. What's the typical period for tangent? Pi. And you're dividing by b. Where's the b always located? The coefficient of x, which in this case is 1/2. So I'm going to take pi, and I'm going to divide by 1/2. So it looks like I'm dividing fractions, so we multiply by the reciprocal of fraction number 2. So it looks like it's 2 pi. Then what? The length of each interval, because it looks like you just doubled the period, which means the length of each interval is going to change, yes? Okay. So the new period divided by 4, because there's there's 4 intervals when you graph tangent, not quadrants. Sine and cosine have 4 quadrants. Tangent has 4 intervals. So pi over 2. Wonderful. And then, yeah, we're going to identify if it has a vertical shift. That is the next characteristic anyway. And in this case, yes, I have a vertical shift. It goes up by 3, which is going to change your key y values, isn't it? These are all the characteristics that we find with sine and cosine. This is the order we find them with sine and cosine. Tangent's no different. Like I said, just a little bit of a tweak. So if it goes up by 3, that means now, right, some of us need to break this, that means the key y values are positive 2 and positive 4. Oh, by the way, aren't we going to have a new center line? That's what happens. The old center line was y equals 0, which is the x-axis. Since this is going up by 3, it's going to be y equals 3. That's the new center line, the new 0 line. Good? Okay. But a characteristic that we identify for tangent that sine and cosine don't have are asymptotes. Remember, the normal asymptote for tangent goes from negative pi over 2 to positive pi over 2, not including, because those are asymptotes. In this case, you have a 1 over 2 in front of the x. So now there's a 1/2 in front of the x. So now you have to find out what that 1/2, how that's going to affect the typical asymptotes. So what are you going to do? I have to get rid of this, so I have to multiply by 2 over 1 on the left and the right as well. That's right, negative pi less than x less than 2. Whoops, not 2. I was thinking of canceling the 2. See, this is why you got to do the work with me. Less than pi. These are my new asymptotes. Good? Okay. So, let's start putting things together. We have our asymptotes at negative pi. See, I'm used to the old asymptote, negative pi over 2. So we have the new asymptotes at negative pi and positive pi. There are supposed to be 4 intervals. Okay. And I have to add pi over 2 to get from here to here. So that's negative pi over 2. And if you didn't get that, pause the video and literally write down negative pi over 2 plus pi over 2. Do the math, common denominator, etc. Good? And now negative pi over 2 plus pi over 2 is 0, because that's the length of the interval. 0 plus the length of the interval pi over 2 is pi over 2. And add one more time and we get pi. Yay! Okay. We have a new center line, don't we, of y equals 3. And our key y values are 2 and 4. And this is the new center line of y equals 3. Y'all with me? Okay, so now I have my asymptotes here, right? Okay, time to come up with the graph, right? Okay, so here we go. I'm running out of a little room. I'm going to put it up here. Hopefully I have enough room up there that it works out. Let me grab my smaller pen to do it. Okay. So the x's that we're plugging in. We're plugging in negative pi over 2, 0, positive pi over 2, and pi. And the first thing according to this equation that we're supposed to do is multiply by 1/2. So we get negative pi over 2, negative pi over 4, 0, positive pi over 2, positive pi over 4, let's get rid of that guy, and then positive pi over 2. Aren't these the typical angles we use for tangent? Yes, because the next thing we're doing according to that equation is taking the tangent of these angles. All right, what's the tangent of negative pi over 2? Undefined. The tangent of negative pi over 4, negative 1, of 0, 0, of positive pi over 4, 1, of pi over 2, undefined. Got it. And then, according to that equation, you're supposed to add 3 to all of that. Well, that's still going to be undefined. That's going to be 2, that's going to be 3, that's going to be 4. This is still undefined. And now the point. Negative pi is undefined. Negative pi over 2 is 2. 0 is 3. Pi over 2 is 4. And pi is undefined. Cool? Good. Loving it. How are you doing with this chart? Is this helping? Loving it. Okay. So here we go. Negative pi is undefined. We already knew that. That's what we got here. Negative pi over 2 gives me 2. 0 gives me 3. Pi over 2 gives me 4. And pi is undefined, but we knew that already. So when we graph these dots, connect the dots, this is the graph we get. Yay, that's what we were supposed to get. Everything's meshing. Everything's checking the boxes. Verifying with each other. Good? Okay, I have one more problem coming your way, so stay tuned. Hey there. Problem number 3. How you feeling? Confident? A little more confident about graphing trig functions? Especially tangent, since that's what we're talking about. Okay, let's get started. What'd you identify first? Good, you identified the amplitude. What's the amplitude in this case? Yes, we have an amplitude of 1/2, which tells me key y values. What are my key y values then? Negative 1/2 and positive 1/2. Great. Then what? Ask yourself, is this going to flip? Will it? You're right, it will not. So this is the way the tangent graph should face, agreed? Then you're going to identify the period. And what's the typical period for tangent? Pi. It only takes up half the circle. And you're going to divide by b. Where do you find b? Coefficient of x. So in this case, it's going to be pi divided by 1 over 4. I'm dividing fractions again, guys. We're going to get very good at doing this. So it looks like the period for this particular tangent graph is 4 pi. Got it? Okay, now what? Yeah, I've got to find the length of each interval for this new period for this tangent graph. So we're going to take 4 pi and divide by the 4 intervals that we're going to work with. So the length of each interval will be pi. Good? Excellent. And now, asymptotes. No, not yet asymptotes. Right, because you guys are telling me, hey, we have a vertical shift. You're right, we do have a vertical shift. In this case, it goes down by 2. So that means I have got to minus 2 from each of these key y values. So I know what the new key y values are. Okay, so key y values. And if you have to pause the video to do the subtraction, then do it. But I'm assuming you already did it. So we have negative 5/2 and negative 3/2. Some of you are like, I put it as a mixed number. Put it as improper fractions. It's usually the way that we like to identify things. It's funny, we don't use mixed numbers too often, even though we've learned to work with them. New center line, yes? Okay, so what's my new center line? Yeah, it's going to be y equals negative 2, because everything went down by 2. Wonderful. Now the asymptotes, good job. All right, so let's see what happened to the asymptotes. The normal ones go from negative pi over 2 to positive pi over 2, right? Not including them because those are asymptotes. But the new one has a 1 over 4 multiplied to the x, which tells me I need to figure out what that's going to do to these asymptotes, to the original ones. So multiply by 4 over 1 on left and right besides the middle. All right, what'd you guys get? Because you were supposed to have done this problem already, or the work already. Negative 2 pi, I hear you. Less than x, less than positive 2 pi. Okay, so it looks like those are my new asymptotes. So when I start this, putting my graph together, all my key y values are negative, so I'm going to have to kind of put my x-axis up here. So we have negative 2 pi as one asymptote, positive 2 pi as another asymptote. I still have 4 intervals, and the length of each interval is pi. So negative 2 pi plus pi is negative pi. Another pi gives me 0. Another pi gives me pi. Another pi, 2 pi. 1, 2, 3, 4 intervals. Wonderful. And asymptotes are at negative 2 pi and positive 2 pi. Good, good, good. Well done. Okay, what were those key y values? Looks like they were at negative 3/2 and a negative 5/2. And it looks like our center line was at y equals negative 2. Okay, doing good. The only thing now is I need room for my chart, huh? I'm going to put it up here. It looks like I have enough space. And I'm going to use my thinner pen to help save on space. So, my x's. Here are my x's that I'm plugging in. Negative 2 pi, negative pi, 0 pi, and a positive 2 pi. And according to this equation, the first thing you do to the x is multiply by 1/4. So you already did your work. I have to do my work. So what is that? Negative pi over 2, negative pi over 4, 0, pi over 4, and then pi over 2. My typical angles for tangent, which means I should be taking tangent next, and I am. Yay, things are working out the way they're supposed to. Okay, you know what this is. What'd you guys get for negative tangent of negative pi over 2? Undefined. And for negative pi over 4? Negative 1. And for 0? 0. Positive pi over 4? Positive 1. And undefined. Got it. Okay. What's the equation tell me to do next after I took the tangent? Multiply. You have to multiply before you subtract. So multiply by 1/2. Well, that's still undefined. That's negative 1/2. That's 0. That's positive 1/2. And that's still undefined. And then I have to minus 2. Last but not least. Okay, well, you're still undefined, aren't you? What'd you guys get here? Negative 5/2. Negative 2. Negative 3/2. Still undefined. And then, yeah. Tell yourself what points you're actually plotting. Negative 2 pi and undefined. Negative pi and negative 5/2. 0 and negative 2. Pi and negative 3/2. And 2 pi and undefined. All right, guys, here we go. Negative 2 pi and undefined. We already knew it was an asymptote. We figured it out, but it checks it, and that's important. negative pi and negative 5 halves, 0 and negative 2, pi and negative 3 pi over 2, 2 pi and we already knew that was an asymptote also. So when we connect our dots, hopefully my graph looks better than it did last. There we go. And that's exactly the way it should have gone. With me? How are we doing? Does this make sense? Okay. Whether I'm graphing sine, cosine, or tangent, I find the same characteristics in the same order every single time. The only trig function that needs tweaking is when it comes to tangent. Key values, asymptotes. Got it? Okay. Have fun with tangent. Catch you on the flip side.